All right, so this one's only asking for the perimeter. Okay, so I don't know if I answer that correctly, if it asks me for another part. Does it? Okay, so we do eventually want the area. So remember finding the perimeter. Okay, this is a hexagon, right? Okay, so this distance that they're giving me right now, 13 radical 3, what segment do you call that? That's the apothem. Okay, we need to draw that triangle right there, okay, to generate the distance right there. Is that okay with everybody? And once I find that distance, what can I do with it to find a side length? Times it by 2, and then do what with it to find the perimeter? Times it by 6. Okay. You can do that in one step and just multiply that number by 12, or you can do it in those 2 steps of 2 and then 6. So this angle right here is going to help decide what these distances are. In this hexagon, and really for all figures, that angle, that half central angle, is found by using what formula? Okay, so half the central angle is equal to 360 divided by 2n. So in this case, it's be 360 divided by 12, which would give me 30, right? Okay. Now, I'm just going to draw that triangle a little bit bigger here to help myself visualize things. But that is across from now the 60-degree angle, and this would be the 30-degree angle, correct? Does that make sense, everybody? So if this is across from the 60, that's our n radical 3 side, right? In a 30, 60, 90. So what's n going to be? N is 13. Okay. Now n, going back up to our figure, n is that side right there, right? It's across from 30. So if I take 13 and double it, a side length would be 26. The perimeter then, okay, is going to be, what's that, 156? 25 times 6 is $1.50, right? And then 6 more will be 156. So that's my perimeter. So type that in. And then it says units. So that's in centimeters. So it's got to be centimeters squared, right? What'd I do? Your answer to the value perimeter is correct, but your answer for it, unit, is incorrect. What'd I click? Oh, yeah, what am I doing? I'm sorry. I was already thinking we were doing area. Thank you. All right. So now the area. Now the area would be 1/2 the apothem. What was the apothem? 13 radical 3 times P, which is your perimeter, which was 156, right? Now, if they want nearest tenth, we can grab our calculator and type that in. Let's see here. What I would do, and I'm not saying what I do is right, but I'm interested. If I take 156 and multiply it by 1/2, that gives me 78. Okay, so then I take 78 times 13, and get 1014. So 1014 square root of 3 is the exact answer. Does that make sense to everybody? Okay, I can type this in. That's the exact answer right there, if they were to ask for that. But this then, because that's the exact answer, then this is accurate out to that 9. So if they want to the 2nd place, 3rd place, 4th place, I can do that. Is that all right with everybody? You can get the same thing by going 1/2, 13, square root of 3, and times the 156, just like we wrote it by hand. Okay? But if they were to ask me, what is it as an exact value, do you see how Desmos doesn't take that and simplify it for me? Down to that. So that's what I always do. And I know it might be frustrating for students because you're like, they just want tens place, hundreds place, whatever. But when we get to end of course exams, they might want exact answers. When you get to ACT, they want exact answers. Okay? If we never focus on that, even though Math Excel doesn't ask for that, we're not going to be successful in those other assessments. Does that make sense? Remember, Math Excel is just a tool, and getting through these homework assignments is just a situation where it can provide you practice, but it's not the end-all, be-all. Okay, just getting through Math Excel isn't the goal of this class. The goal of the class is to be successful in every arena that we're asked these types of questions and the different varieties and variations that they might ask us. Does that make sense on how to do that one? Any others? All right, so the way the question is written, because it's in the section here, they want you to view this as a regular polygon, which it is. Okay, regular meaning all sides the same, all angles the same. So if right now they have the radius. If I draw that down, that's my apothem, right? Okay. Now, if I look at this angle right here, which is always going to be found by taking 360 divided by 2n. In our case, it's 360 divided by 8. Gives us 45 degrees, right? Okay. So I'm just going to draw that triangle over here to the side. If this is 45 degrees, and this is a right angle, and this was 5, isn't that your n radical 2 side? So how do I take, so 5 equals n radical 2. Should I divide by radical 2 to get n? Okay, so this side here is 5 over radical 2. Okay, now if you want to rationalize that, go ahead and do that. You get 5 radical 2 over 2. That is what this side right there is. Everybody okay with that? 5 radical 2 over 2. Is that what this side is as well? 45, 45, 90 triangle is isosceles, so those two distances have to be the same. So when I try to find the area, it's 1/2 AP, so 1/2 the apothem, 5 radical 2 over 2, times the perimeter. So if I go find the perimeter, I need to find that distance first, right? Isn't that distance going to be twice as big as that one? So if I double that, it gives me just 5 radical 2. So a side length is 5 radical 2. So what would be the perimeter be? I would multiply this by 4, so it's going to give me 20 radical 2. Okay. Now, as I multiply this through, you can do a couple different ways. 1 times 5 times 20 is 100. Radical 2 times radical 2 is 2, right? And on the bottom, I'm going to have 2 times 2. Those are going to cancel, aren't they? What's 100 divided by 2? 50. And 50 square units for this triangle. Okay, or not triangle, square. Okay, that's one way of doing it. Okay, another way of doing it is that once you had this, okay, the technique we used was 1/2 AP. But is the area of a square also this, s squared? So I could go s being 5 radical 2 times then 5 radical 2. What's 5 times 5? 25. And what's radical 2 times radical 2? 2. So it gives me 50 that way, right? What other figure is a square? It is a rhombus, and it is a rectangle. The rectangle one formula is B times H. It's going to be the same thing here, but B and H are the same. I want to go back to that rhombus idea. And now the reason I would want to maybe use the rhombus formula here instead of any of the formulas we've run through so far, what's the diagonal of that square going to be? It's going to be 5, right? Now, or sorry, not 5. It's going to be 10, okay? And we have to realize that this is a rectangle, okay? And that tells us that the diagonals of a rectangle are what to one another? They're congruent. So if a square is a rectangle, a square is going to have congruent diagonals. So that means D1 is 10. This entire diagonal here would be 10. So what would this diagonal be? 10 as well, right? What's 1/2 of 10 times 10? 50. So per what they give me, one of these formulas might be better than the others. If they give me the radius of a square, which is basically what they started with here, it probably makes more sense efficiency-wise to use 1/2 D1, D2 to view the square as a rhombus. If they gave me a side length, doesn't it make more sense to view that square and find its area by side squared? Okay. If they give me the apothem, I would probably at the same time use side squared. Okay. I don't know that there's ever a situation that 1/2 AP is the go-to formula for finding the area of a square. Does that make sense? Because it's going to be, there's other tools that are more efficient. It works, and that's what they're getting at here, is just to show you that it does work, but you've got better techniques, better ways of doing it. And, you know, if you go outside your house and you've got a skateboard, a bike, or a car, and you got to get to work the fastest, how are you going to do it? You're going to use the car, right? Okay, that's the most efficient tool at your disposal. I think I always use an example. If I've got to dig a hole and I've got a spoon, a shovel, or a backhoe, which one am I going to dig the hole with? Backhoe, right? Okay, that's going to be easier. All right. So same idea. Use the correct tool for the problem being presented. And the reason I say that is because obviously this is in 10.3. They're trying to get you to use 1/2 AP. But when you type an answer in, does the answer know that you chose 1/2 AP or that you did 1/2 D1, D2 or anything like that? No. The answer, and that's what, and I know you've been in class. You ever been in class where a teacher says, you've got to do it the way I do it? Have you ever heard me say that this year, that you got to do it the way I do it? No, okay? Because my philosophy is we get to the answer, okay? Can we get to the answer, and can we justify or explain our answer, or the method that we use to get our answer? That's what I'm worried about, okay? I never want somebody, because there's so many different ways to approach all types of problems, and that's, remember, a byproduct of teaching math. Are you guys going to probably use this in your real life? You use 1/2 AP ever? I never have, okay, other than teaching it. But the byproduct of problem solving, you're going to use every single day, and probably use it almost every instant of every day. And we know, hopefully, that the problems that we come across, there's going to be more than one tool, more than one procedure for tackling that problem. Okay, so just keep those types of things in mind. Any others? Say 19? Okay, so some of you might, so if I toggle back and forth, you might get different shapes. Okay, so Connor, you asked about, did you get a square on the one that you asked about? You got a hexagon? Okay, so let's do it. We'll do the one with the triangle, and we'll do one with the hexagon. So if that ever happens, and that's, you see, they pull from a pool of questions, and I only see that it was giving everybody the square, so I apologize for that, but we can do a variety of these. Now, this one, and I don't really care for where they draw that segment right there, but what segment is that if we're looking at our regular polygon? Say again? That's the radius, okay? Because it goes from the center to a vertex, okay? Now, that distance there then, if it's perpendicular, that distance would be the what? The apothem, right? Okay. I always like to look at, and it's just the way my mind works. I always like to draw my apothem straight down to the bottom of my page, or the bottom of my picture, and I like to draw the radius to the right vertex. It's just what I do. I try to keep things consistent all the time. So I'd be looking at the information from that triangle, but what do we know about that triangle compared to this triangle? They're congruent. Okay? So however you see that image, I'll use what they gave us here if you drew it this way. But you can look at any one of these little triangles that you want. So this is the half of my central angle. Okay, so we got to find that measurement. So now that angle, okay, so half, let's just call it half of CA, half the central angle, remember, is 360 divided by 2n. So 360 divided by 6 in this case would give me 60 degrees. So if that's 60 degrees, this is 30 degrees. This radius that they gave me, what segment is that for a 30, 60, 90? Across from the hypotenuse, across from the right angle, it is the hypotenuse. That 3 is what? It's 2n, okay? So I'm going to rewrite this. So this 3 is equal to 2n. So n would be 3 over 2, right? And n is always across from 30. So this distance right here is 3/2. And that's your apothem. This distance here is going to be n times radical 3. Is everybody okay with that? So when I find my area, it's going to be 1/2 apothem times perimeter. Apothem is 3/2. Now we just got to figure out what our perimeter is. Okay? So right now, we have this distance being 3/2 radical 3. What do I do with that to get that distance? Times it by 2. And when I times it by 2, it's just going to make that 2 disappear, right? So it's going to be 3 radical 3. And then what do I do with that number to get the whole perimeter? Times it by 3 again, so I get 9 radical 3. Okay? I like to leave it as an exact value, so I'm going to go 1. I'm going to multiply straight across the numerators. 1 times 3 times 9 is 27 times the radical 3. Across the bottoms, 2 times 2 times 1, and it gives me 4. And then 27 and 4 are relatively prime to one another, which means they don't share any factors. So it's fully simplified in that version right there. If you want it as a decimal, you can convert it to that as you see fit. If we get a hexagon, see if I can, there we go. So getting the hexagon image here, what segment do they give me in this one? It's the radius again. So in all of these, the square, so no matter what shape you got, they gave you a radius, okay? And the shape that you got was either a triangle, a square, or a hexagon. And the reason they did that is because when I find that angle right there, half that central angle, in all of those shapes, just like this one, when I go 360 divided by 2n, so in this case 12, it gives me 30, right? Okay, so they're always producing, when it's a square, a hexagon, or a triangle, that central angle is going to be 30, 60, or 45, so you can use special right triangles. Okay, they give me 4 to be the hypotenuse. That's my 2n side, right? So what would this distance here be? 2. And your apothem is going to be 2 radical 3, right? So I go area is 1/2 A times P. 1/2 my apothem, which is 2 radical 3. And now my perimeter, if this side here is 2, or that segment is 2, what is this side of the hexagon? 4. And what's the perimeter then of the hexagon? Be 4 times 6, right? For that 24. What's going to happen when I multiply 1/2 and 2? Cancel, right? I'm left with 24 radical 3 as my final answer. Is that okay? Do we have quite a few more of these to do?